Computer science in artificial and intelligence. So, in today's presentation, we will be studying about wind energy and properties of wind. Moving on, let us see the introduction to wind energy. Wind energy is a rapidly growing renewable source of electricity generation. It leverages the natural power of wind to spin the turbines and produce clean, sustainable power. As an abundant and environmentally friendly resource, wind energy plays a crucial role in the global transition to renewable energy. Understanding wind. Wind is a natural movement of air caused by differences in atmospheric pressure and temperature. It is driven by the uneven heating of Earth's surface by the sun as well as rotation of the planet. Understanding the characteristics of wind, such as its speed, direction, and turbulence, is crucial for harnessing its power of renewable energy generation through wind turbines. Let us see the characteristics of wind. The first one is speed and direction. Wind speed and direction are crucial factors that influence wind energy potential. Understanding the local wind patterns is key for optimal wind turbine placement. So based on the direction and speed of the wind, the turbines are placed at that particular area, so it provides maximum efficiency. The second is variability. Wind speed and direction can be highly variable, fluctuating throughout the day, season, and a year. This variability must be accounted for in wind energy project planning. The third one is temperature. Wind speed is affected by temperature differences, with warmer air rising and cooler air sinking. This terminal activity drives wind patterns and affects energy generation. The fourth is terrain. The local terrain, including hills, mountains, and vegetations, can significantly influence wind speed and direction. Carefully site assessment and crucial effective wind farming development. Moving on, let us see wind power potential. Wind has the potential to generate up to 2 times of world's current electricity demand. 20% global capacity, that is nothing but wind power currently accounts for around 20% of the world's renewable electricity generation. 800 gigawatts installed capacity. The global installed wind power capacity has reached over 800 gigawatts as of 2021. Wind has an enormous untapped power potential that can be harnessed to generate clean renewable electricity. Estimates suggest that global technical wind power potential could be up to 2 times the world's current electricity demand, showcasing the massive scale of this energy source. Currently, wind power accounts for around 20% of world's renewable electricity generation, with the global installed wind power capacity surpassing 800 gigawatts as of 2021. The rapid growth demonstrates the increasing viability and adoption of wind energy technologies worldwide. Moving on, wind turbine technology. Wind turbines are the core technology that converts the kinetic energy of wind into electrical energy. They feature large rotating blades that capture the wind's force and drive the generator to produce the electricity. Innovative blade designs and advanced control systems optimize energy generation and efficiency. Rapid achievements in wind turbine engineering have led to taller towers, larger rotor diameters, and high power outputs. Offshore wind farms leverage even bigger turbines to harness the stronger, more consistent winds found at sea. Moving on, wind farm development. Site selection. Identify optimal location based on wind sources, land availability, and grid connectivity. Project planning. Conduct feasible studies, obtain necessary permissions or permits, and secure financing. Construction. Install wind turbine substation and transmission infrastructure. This comes under wind farm development phase, whereas operations is nothing but maintaining and optimizing wind farm performance, monitoring energy generation. Developing a successful wind farm requires careful planning and execution across multiple stages. Site selection is crucial, ensuring the chosen location has to be strong and consistent, availability of land, and proximity to the electrical grid. Detailed project planning, including feasibility studies and permitting, lays the groundwork for efficient construction. Once operational, ongoing maintenance and optimizations are essential to maximize the wind farm's energy output and economic viability. Moving on, environmental impacts of wind energy. Land use. Wind farms require large area of land which can impact local ecosystems and disrupt habitats. Careful site selections and planning can minimize these effects. Wildlife impacts. Wind turbines can be threat for birds, bats, which can collide with the blades. Strategies like proper sitting and deterrents are used to reduce wildlife impacts. Visual and noise impact. Wind turbine can create visual and noise pollution that affects nearby communities. Minimizing these impacts through designing and community engagement is done. Economic and social benefits. Job creation. The wind energy generates a significant number of jobs from manufacturing and construction to operation and maintenance, providing employment opportunities in both rural and urban areas. Energy security. Wind energy reduces reliance on imported fossil fuels, improving a country's energy independence and security of supply, which will be crucial for economic stability and national security. Affordable. Once installed, wind farms produce electricity at low, stable cost, helping the keep electricity prices down and making it more accessible to household and businesses. Sustainability. Wind energy is renewable, clean source of power that doesn't produce any greenhouse gas emissions, contributing to an eco-friendly, sustainable future and mitigating the effects of climatic changes. Challenges and limitations. Grid integration. Integrating wind power into existing electrical grid can be challenging due to intermittency and variability of wind. Maintaining grid stability and balancing supply and demand requires advanced grid management technologies. Site selection. Selecting suitable sites for wind farms is crucial but can be limited by factors such as land availability, wind resources, environmental consideration, and community acceptance. Technical limitations. Wind turbine technology continues to improve, but there are some technical limitations in terms of blade size, generator capacity, and overall efficiency that can constrain maximum power output. Economic barriers. The upfront capital cost of wind power can be high, so these kind of challenges will be faced. Conclusion, and let's see the future outlook. As we explored the many facts of wind energy, it is clear that it holds great promise as a sustainable and renewable power source of the future. With ongoing technology advancements and increased global adoption, the future outlook for wind power is bright and full of potential. Thank you.